Okay, so when it is greater than, you are writing two separate inequalities. We flip the sign, make the number negative, and then we copy this down as if there was no absolute value there. And now I'm doing both inequalities. I'm subtracting 5. 3x is less than or equal to negative 16. I'm dividing by 3. And x is less than or equal to negative 16 over 3. I'm subtracting 5. 3x is greater than or equal to 6. And I'm dividing by 3. And my x is greater than or equal to 2. And that is the algebraic solution right there. Okay? Now, when I go to graph it, negative 16 over 3, 0, 2. The greater than or equal to, less than or equal to are closed dots. And greater than or greater than equal to will always go in opposite directions. My set notation indicates that as well. Negative infinity to negative 16 over 3, bracket. Bracket around the 2 to infinity, parenthesis. And this right here is my entire answer. I've got to answer algebraically, graphically, and through set notation. Okay? With a less than, and I know it might have been a little confusing, that little line through the less than, that's just how the computer does it. That's a less than sign. It'll be obvious when it's less than or equal to or greater than or equal to. We have to write it as the combined statement. Oops. We have to write it as the combined statement. We're adding 7 to all three sides. Negative 4 is less than 4x is less than 18. We're dividing everything by 4. So my algebraic answer is negative 1 is less than x, less than 9 over 2. With a graph, negative 1, 0, 9 over 2. Open dots because it's less than, and we connect. And then parentheses, negative 1 and 9 over 2. There's my answer. So the next two here, since it's a greater than, it's x minus 3 is less than negative 15, and x minus 3 is greater than 15. So I'm sorry, x minus 3 is less than negative 15, x minus 3 is greater than 15. I'm going to solve both algebraically. 8x is less than negative 12. We divide by 8. I'm going to reduce right away. X is less than negative 3 halves. I'm going to add 3 both sides. 8x is greater than 18. We divide both sides by 8. And x is greater than 9 over 4. And that's the algebraic answer. My graphing answer, negative 9 halves, 0. Ooh, I'm sorry, not negative 9 halves. Negative 3 halves. 0 and 9/4. It's an open dot to the right. It's an open dot to the left. And then negative infinity to negative 3 halves. 9/4 to infinity. Those are my answers. With a less than or equal to, negative 39, we write the compound statement. Negative 39 less than or equal to 9x plus 6, less than or equal to 39. We subtract 6 on all three sides. Negative 45 is less than or equal to 9x, which is less than or equal to 33. We divide all of them by 9. Negative 5 is less than or equal to x. I'm going to reduce this over here. Less than or equal to 11 over 3. And now my graph, negative 5 and 11 over 3. Since it's a combined statement, the dots are connected and the dots are closed because less than or equal to. And then less than or equal to means negative 5 and 11 thirds are enclosed by brackets. And there's my answer. The average number of seeds in a package of cucumber seeds is 21. The number of seeds in the package can vary by 6, which basically means I've got to come within 6 of 21. In the back of my mind, I should already be able to come up with that answer. I need to either be within 6 below 21 or no more than 6 above 21. So whenever we do this, it's an absolute value, and it's x minus whatever number I'm trying to achieve, which in this case is 21. And it's always less than or equal to the wiggle room I have, or the variance I have of 6. And then it's basically what we've been word problems, you don't need to graph or solve with set notation. You just need to give me the answer. So in this case, the answer is somewhere between 15 and 27. And that's my answer. And the last one, as we talked about last class, if it's an absolute value and it's less than a negative, that's a no solution. An absolute value can never be less than a negative. If it's an absolute value and it's a greater than the negative sign, it's all real. Because every absolute value is 0 or bigger, so it's going to be bigger than a negative number. So less than a negative number or equal to a negative number that an absolute value is, that's no solution. If the absolute value is greater than the negative number, that would be an all reals.